Good morning, everyone. This is Dana Jensen from the Air Force's Office of Commercial and Economic Analysis here on a rainy morning in Northern Virginia. Welcome to the Advanced Air Mobility Supply Chain Working Group meeting centered around the current state of the art for eVTOLs and drones. With me today, I have PK, co-hosting for NASA, and Kirsten Bartok, who is an aviation SME if there ever was one. So, given the topic, I thought I would opine a little bit here at the beginning, just to kind of think about what is the state of the art, right? Because, I mean, to me, the feedback I get from the industry is the real state of the art is to be as low tech as you can get away with, right? The idea is you want to burn down the risk by using existing technology as much as you can, because to the extent that you're involved in cutting edge technology, you're exposed to more risk, both from a certification standpoint and just from a tech standpoint. So your system, you want to burn down as much risk as you can by staying as low tech as you can be. So counterintuitively, I think the state of the art also involves trying to stay as non-cutting edge as you can be. I had one vehicle OEM come up to me and say that they wanted to make their vehicle as stone age as possible. And that was what they tried to go after. And I thought that was that's a clever approach. Although I would argue that if you combine enough of those Stone Age components together in clever and novel ways, you do get a machine that certainly looks cutting edge. And that combination of technology certainly, is a radical improvement, or otherwise we wouldn't be here. Another aspect of state of the art is modularity, right? That you want to be future proof. I think everybody recognizes that the state of the art and the state of the technology is going to evolve over time. So to the extent that your vehicle is modular, for example, you take a certain kind of CAN cell battery, the kind of Gigafactory 2170 or whatever, and you ask the OEMs and they're like, yeah, we intend in the future to swap these things out as the chemistry gets better. And we also want to be vendor agnostic, right? And that's another great approach to being more resilient, is the fact that you can move between vendors more seamlessly if one of them, goes out of business or their tech starts lagging. So between those two things, that sort of future proofing and the use of as low tech materials as you can get away with, I think are kind of the state of the art now, or at least they're design philosophies that seem to be shared among a lot of the major OEMs. The other thing I'd like to just flag for everybody is McKinsey Global Institute did a paper last month called Risk, Resilience, and Rebalancing in Global Value Chains. It's a long report. It's over 100 pages, but there also is a 28-page executive summary. I highly recommend, if you have time, reading through that. I think it approaches a lot of the things that we're discussing here. It talks about resiliency. It talks about shocks, the frequency and the magnitude of shocks and how firms do or don't optimize their supply chains to deal with those shocks. And they talk about, the idea that you want to build redundancy in your supplier network, maybe consider holding more inventory, keep product complexity to a minimum, which is part of our point about the state of the art. And also, improving transparency like we are here with thinking about supply chains. So with that, I'll hand it over to you. Anna, do you want to go over just the kind of logistics for today? Oh, here, I'll go through the schedule. No problem.
Perfect. Thanks, Dana.
Here's the next slide. So right now, obviously, this is me welcoming you again. Welcome. Next, we're going to hear from Kirsten Bartok from Air Finance about the urgency and need for a resilient supply chain for drones and eVTOLs. Then around noon, we'll kick it over for discussion, Q&A, and interacting with you guys to the extent that we can through the conference's IO and the chat. And really, like to keep these things informal and discuss as much as possible, because Kirsten's got a lot of good industry knowledge, and we'd like to get that. We'd like to coax that out of her as much as we can here at the end. And then we'll do some closing remarks by PK. I don't know that we'll run the whole time, but we'll certainly talk until it seems like it makes sense to stop. So other than that, over to you, Anna.
Perfect. So just a couple of logistics. As you saw when you all registered for the event, there's two types of participation. There's active participants and listen-only participants. The active participants, you all are here in the Microsoft Teams room. So the goal is we want you to be as active and a part of this discussion, interacting with each other and the host as much as you can. So we encourage you to use your microphone, the MS Teams chat functions. However, there are a couple of requests we do make. One is, if possible, please leave your camera and webcams off. That's just to preserve bandwidth. With over 50 people in this meeting now, we want to make sure we don't lose any connectivity. Please remain on mute unless you are speaking. Naturally, if you're speaking, please unmute and share what you would like with the group. Feel free to enter questions and comments in the MS Teams chat. We want this chat to more be a resource for all of you to interact with each other and to really start a dialogue together. We may address some of those questions periodically throughout the presentation, but that's more a resource for all of you to interact together. If you would like to speak and discuss the topic, please use the raised hand feature, and we'll do our best to call you in the order that your hands are raised. And one more favor is to say your name and affiliation before you begin speaking. The goal there is just we know where you're from, who you work with, and we can help add a little context to what topic you're bringing up for discussion. For everyone who is joining us as a listen-only participant, you are watching this through a YouTube live stream. You can access that link on the AAM Supply Chain Working Group website, which that link is on the screen now. And you're able to add questions through Conferences.io. So that link is here as well, and also on that website. So if you want to click that and go there, enter any comments, questions you may have, and Dana and PK will be referencing that and may add in some of those questions if time permits or at the facilitator's discretion to kind of continue the conversation forward and make sure we're hopefully addressing everyone's thoughts, comments, opinions here. So with that, I'm excited. I think this is going to be a great discussion, and I'm going to pass it to PK to introduce Kirsten.
Thank you, Anna and Dana. That's great to be here again. This is our second round of supply chain work group discussion, and I think it's only going to grow and mature in its content. So we continue to hope to have a content-rich discussion and some fun together with you all to build the future supply chain. We are really grateful that we have significant industry participation, as well as our colleagues from DoD and FAA are part of this. So we are thankful for this all entity participation in the future. We are also going to have Department of Commerce together working with us. So it's great to be here. And I will also offer my thoughts on the ecosystem and the state of the art, and Dana has articulated. There is a nice balance of pushing the innovation at the same time maintaining safety and reducing the time it takes to develop the aircraft from design to its inception. Pretty much every modern aircraft has been overweight, delayed, and over budget, and we can't continue to afford to do that. And we are trying to set up a supply chain so that it doesn't happen. We will support that, and that's sort of my mantra is to accelerate the to the race to the scalability at the same time, make sure that the cycle time from drawing board to its inception is as small as possible. So that's sort of the reason why we have this group and look at the complex engineering system that supply chain is to prepare for future. Now, one of the most important parts of supply chain, particularly in the early stages, is the finance. It all starts with the capital investment because supply chain, setting it up, businesses, manufacturing and supplier capabilities is not a trivial thing. It does take a lot of planning and effort and capital. And that is the reason we starting off our speaker series. Every time we'll have a new speaker. Today, we are really grateful to have Kirsten Bartok, who is the founder and managing partner for Air Finance. So she's going to reflect her views on the supply chain and how this needs to be set up. But let me introduce Kirsten a little bit more formally. Kirsten is the founder of Air Finance, and she's the managing partner. She specializes in structured finance, leasing, and finance of the aircraft, with particular emphasis on emerging markets, which you all are part of. So her core business is an originator and surveyor of the aviation loans and a fleet of financed aircraft ranging from Cessna Caravans to Gulfstream. Before she started Air Finance, she was a VP of the Strategy, Structured Finance, and Corporate Development at Beechcraft Corporation. So that was another great experience that she has. And she particularly helped lead the company's expansion into Asia, China particularly at the time, and also led some significant relationships, mergers, and acquisitions. And before that, she was a co-founder and board member and CFO of Exojet, a San Francisco-based private aviation company that was sold to TPG Capital. She's part of the original core executive team that built the Exojet and developed the innovative business jet outsourcing model. So she's very, very familiar with the way the aviation works, the financing in aviation works, and what kind of financing it needs exist today. She has great also education background from University of Pennsylvania, where she was a Benjamin Franklin Scholar, an MBA from Stanford University Graduate School of Business. And she also currently advises Dean of Stanford Business School on strategic issues. She was a Council Foreign Relationships term member, a French-American founding Young Leaders Fellow and German Marshall Fellow, and Young Leader with the Committee on U.S.-China Relations. So with that, I would like to welcome Kristen, and thank you for coming and sharing your thoughts with us and discussing the opportunities as well as offering your help and lending funding to the ecosystem of emerging aerospace. So welcome, Kristen.
Thank you, PK. And I'm always excited to be here. And thank you also for the great introduction. My mother would be proud. I'll take you guys through a presentation I've given a few times. It is broad. I kind of equate this a little bit to going back to business school. For some of you, it's going to be boring and it'll be basic and granular. For other ones, hopefully we'll bring in some new concepts. And then I look forward to a hearty discussion at the end. As you guys will all realize, we all take and share information back and forth. So I have to give attribution. Many of my ideas come from PK. And then it involves some others. So it's a small universe, as you all know, being here, and we look forward to participating. So with that, let me go to my presentation. I talk fast, so please don't hesitate in having me go backwards, and I am happy to do that. So I'll also give a little better idea of why someone with such a general aviation background is joining you today. So, perfect. So we're here to talk about the future of air mobility and who will own it. And most of you are familiar with that topic. As PK expressed, I've got a kind of a random background. I've spent time in venture capital, in finance, and also starting up a fleet, a 135 operator, an OEM, and now as an international financier. People often ask, what do you have to do with air mobility? Why are you here? And I describe myself as really kind of the conduit between Silicon Valley and aerospace. And I know PK plays that role a lot, as does Dana. But I moved to Silicon Valley 2 decades ago and really started up investing in venture capital and startup world back in 1996, 97, so really early. And I always joke that I wish I knew, now what I could see now. And this is partly what's brought me to advanced air mobility, the recognition that we are about to enter a whole new world. And I look at my position, well, I'm an active investor in early stage aerospace technology companies, especially around air mobility, and that's primarily why I'm here. I also help kind of bring the worlds of fundraising, venture capital, aerospace, and technology together, and really help those groups talk to each other and understand how those different worlds work. So you guys all know why we're here. What makes this revolution different? It's about electrification, distributed propulsion, and autonomy. And those 3 extremely large changes, which are going to make the future of aviation, how we look at the next 20 to 50 years, entirely different than how the prior 50 years have looked. I often joke that we don't know yet what the optimal design of a future aircraft based upon autonomy, distributed propulsion, electrification is going to look like. And I find that so exciting. So where are we today?
So Kristen, just one suggestion. I don't know if you're able to put that in the presentation mode, if it's easy to do that.
It says to me I'm in presentation mode. Okay, hold on.
Okay, so yeah, sorry to interrupt.
Is it? No, I'm glad you did. I'm going to get back out of presentation. So have you been looking at me, PK, the whole time and not seeing my slide?
No, we were looking at the presentation, but it was not in the presentation mode. It was kind of a slider with the view.
We can show the and the notes as well.
All right. Well, that's possibly because I'm using multiple screens. So let's see if that helps.
If not, don't worry about it.
We're going to give this a try. Is that any better? Technology, we think it's our friend, and then it's not, right? So let's go back out again. I'm going to go into, it's highly frustrating, everyone. Hold on. Back into, we go in here, one more try, and then you may have to look at all of it.
That would be totally fine as long as you don't have a bunch of expletives in your notes.
Okay, let's try and go here and see if this works. You guys are seeing everything now. Is that it?
We are still seeing everything, but that's okay.
Yeah, click on the play, see what happens. Click on the play right there. Yeah, okay. On that button right there, play button.
The play, that's what I did, the play button, and it still did not work.
Kristen, may I suggest maybe changing the view options in the top left corner?
Yes, I was thinking that was right there, correct?
On the left, all the way at the left.
All the way here?
Yeah, where the view, it says view, yeah.
Perfect, maybe that will help. I still see this presentation notes.
And play.
Is that showing you?
Oh, we still see the notes.
Yeah, but that's all right. Let's
give me one. So
yeah,
about the so the Gartner hype curve I'll talk about while I try, and I think you can say customize preventer display, and I can get out of some of these. Can you see the notes still?
Yeah.
Okay, there we go. How's still?
Unfortunately, yes.
I can't see the notes, so I'm amazed that you guys can see the notes. So.
Oh, so maybe multiple display. Yeah, it's okay. Don't worry about it. I think it's actually, it's quite all right. The YouTube will actually benefit from the. Oh, this is good. This.
Okay.
That looks good.
There we go. At least we have a slide layout over here, but and that. How's that, guys?
Good. Yeah. Okay. Yeah, that's great. Thank you.
Okay. No, appreciate you telling me that. So one of the concepts I want to talk about here today is the Gartner hype cycle for emerging cycle. And here you have, what we have is the innovation trigger and the peak of inflated expectations. These are typically the times in which a lot of venture capital money tends to come in. They are early in the customer expectation and product rollout process. And they really people can see the vision, but they haven't yet had the opportunity to use the product, try the product, and work with it. After that, you hit the trough of disillusionment, which often happens when the technology doesn't evolve as quickly, or it doesn't have all of the capabilities that are envisioned. And later on, we hit the slope of enlightenment. And I think what we have to understand in this space is that these are all normal parts of the hype cycle. And we have to recognize that once we hit a trough of disillusionment, that things take longer than we want, that we will make it through. You can see we're here. This is 2019. We're a little further along, but we're still early in the overall process. Here's the drone industry in 2015. Small group, somewhere around 350 companies. And here's where we are in 2019, well over 1,100 companies and more in 2020. So we're rapidly evolving, we're iterating, but we still have yet to show successes. And by successes, I mean financial successes, companies that are out there making significant money and return the capital to investors that we start with. Here's where we are with eVTOLs. A lot of you come from the industry, you know exactly where we are, but today, when you talk to kind of an uninformed group, they talk about the 200 plus vehicles that have been announced and are out there. Now, we all know that not all of those are going towards certification, they're only a limited handful, but there has been well over $2 billion invested in the space, and that money keeps going up. For so many people, that sounds like a lot, but to the amount of capital we need to get towards certification, as PK pointed out earlier, certifications are usually late and they're usually over budget. And historically, in the general aviation, never mind, this is not considering commercial aerospace, it takes about $1 billion to bring an aircraft from the beginning to certification and production certificate. And that doesn't even include being your own 135 provider. So I have a challenge that I often speak to people, and this goes as well to supply chain. Where will the billions of capital that we need to start at these companies, whether the supply chain, the UAVs, the UTMs, and where will that come from? And part of that is having a virtuous cycle. And to do so, we need to demonstrate some early commercial successes. And this applies to the supply chain as well. And what do I mean by that? There's a concept that has been well honed in Silicon Valley called the minimally viable product. And what that means is you get your minimum crappy products no one wants to use, and then you have products that are built that everyone wants to use but are viable but may take too much time, too much capital, too much money, and you spend more time thinking and designing rather than commercializing your product. So minimally viable product goes back to the theme that we need to come up with the smallest version of the product that is a good product that someone will buy from startups. And again, Dana mentioned this earlier. This kind of goes back to the simplicity of what we're building. This is not building a car and starting with a wheel and building it up. It starts with a skateboard and then a scooter and then a bike, motorcycle, and then a car. And to oversimplify it, that really is what a minimally viable product means.
Slides aren't moving.
The slides are not moving. I'm having a great day, aren't I? So,
hey, Kirsten, what slide are you on? Maybe we can jump there.
I am on, can you see this now?
Yes, I think,
Okay.
yes, you can see the legacy of large failures on your screen now.
Perfect. We'll just go, again, great day, huh, guys? So,
yeah, don't worry about it. This is all part of
I'm going to go back. It's the fun of it, right? Let's see.
Yes, please don't worry. Well, it's all going to work.
If I can move forward, which is not moving forward for me. Great. And you can't see that.
We can see the slide, but it has not moved. So we can see the legacy of large failures slide currently. That just moved to the minimal viable product slide.
And this is where now I can't go to the next slide. So always fun. Keynote Live.
Are you sharing your desktop or are you sharing just the application?
I'm sharing just the application.
Okay.
I'm going to try it one more time. Is that, and I can't get it. So let me see if I can do this. We'll have to live with it, right?
Exactly. And if you need to manually, that moved it. So
Great.
if you can do that to manually move the slides, that'll help.
Perfect. So let's also talk about why the issue of needing so much capital to make this whole revolution occur is important. And I want to just highlight aerospace over the last 10 to 20 years has had many, many public failures, which has really scared investors away from the space. Some of these have been Eclipse Aviation, where over $1 billion invested, and it blew up and went bankrupt. AAM Aircraft, I'm not sure you guys are old enough. I'm certainly there. I remember when that one blew up. And then Hawker Beechcraft, which was a company that was over levered and couldn't support the leverage and the debt capacity back in 2008. All went bankrupt. So what that has caused is a lot of money has been invested in this space, and it's gone up in smoke, as we like to say. So we need to create a virtuous cycle again, where investors look at our advanced mobility companies.
16th of an inch or more. Yes.
That's pretty serious.
It looks serious to me, yeah.
Now there's noise in the background, so perhaps someone could mute themselves. So how do we do that? So what's our problem? So how is today different? Well, we do have a starting point, which is a strong product. Yes, this is a DJI drone and isn't particularly welcome in the US now, but it's still, we have to give them a great deal of credit for where we got here. So we have a drone. As we look at the natural progression of what I talked, kind of a minimally viable product earlier, it goes from the small consumer drone to the cargo drone to possibly the 2-person multi-rotor and maybe a vectored thrush that we have in the future. But again, we have to consider that to have success points, you really do need to look at this natural progression. Another thing I want to talk to you guys that maybe you heard for those who are from Silicon Valley is the concept of a full stack startup. And Apple is your best example of that. Android and Google are too. But it is a company that makes everything. They make the hardware, they make the software, they sell to consumers, they do everything. To build one of those companies is extremely expensive. So if you look at today, the supply chain we have is not a full stack supply chain. You have suppliers, you have OEMs that aggregate the aircraft, they sell them, other people operate them, other people maintain them. So it really is a distributed ecosystem. And what we have a lot of people, a lot of the VTOLs we're speaking of today are talking about full stack startups where they're going to do everything. And that is incredibly capital intensive. And I often say, and when we talk about full stack companies, we don't even bring in highly regulated industries like we are, where you have the high cost of certification. And one point I often like to make is there's one point of getting to a type certificate. There's another additional cost to getting to a product certificate, a production certificate, which actually in many cases is what held up, for example, the Hawker 4000 or the Honda Jet and delayed those aircraft entry into service for years. So how do we deal with this? So if you need 500 to $1 billion, where's that going to come from? There's multiple different groups. There's venture capital that you know that is akin to Silicon Valley that invests in your early stage startup. There are sovereign wealth funds at the extreme other end. They are governments that invest in strategic and large companies. And then there are strategic investors that we have, like a Boeing Horizon X, like a Airbus Ventures, like a Honeywell, who are active in a space. Now, in a company life cycle, you can see typically we have the early stage, you have seed investors, venture capital, and then later on we have things like the public markets, which will take someone out. But let's talk quickly about venture capital and why they aren't necessarily a great fit for our space. So typically venture investors have a smaller size fund, about 135 million, and they like to write small checks. And they can only invest really a cap of about 10 million in each of their startups, or 10% of their fund, excuse me, in the startups. which means that they really, if their average size fund is 100, 150, that gives them between 10 and 15 million to invest in early stage startups. Well, we need significantly more than that to develop the capital intensive hardware and software companies we're describing, never mind the operation intensive ones as well. You look at growth equity people mentioned, well, that's not really an option. Those are the type of investors that come into a space once the technology risk has been removed and you need to scale up production. So growth investors, the type of private equity investors that will start to enter our industry once you are at the production certificate phase, that the technology risk is behind us and now you need money to ramp. So let's talk also about sovereign wealth funds, which we are seeing a bit in these spaces, and they are going to play an active role in certainly the capital intensive VTOLs that we have. And these are groups like Temasek in Singapore, Mubadala in the UAE, OMERS out of Canada, and they invest large sums of money in strategic industries. Perhaps they want to bring them to their region, perhaps they recognize the transformational aspect, but these are multi-billion dollar, can be as large as $50 billion investment funds that have a lot more capital to invest. Now lastly, and there are strategics, and we are blessed in our industry to have a large number of strategics who have been very active investors in this space. And we're going to talk more about whether that's because they want to have a view of the technology or whether they want to acquire them later. The negative thing that has occurred lately is that COVID-19 has caused a liquidity crunch in many of the suppliers in our commercial aerospace supply chain that are integral to the future of advanced air mobility. And that has caused many of them to pull back on the number of investments they can make. So instead of being able to make, let's say, a $25 million check or a $50 million check, they're either not making investments right now or making those much smaller and limiting the capital that we have. So again, I always thought we come back to the issue of this is a highly capital intensive industry that needs money. One of the this brings me to kind of the next thesis I have, which is historically legacy companies, and that's in the aerospace industry as well as the tech industry, don't innovate terribly well. So without picking on our legacy companies, we can look at Google or Apple. And traditionally, a lot of the technology, especially in Google's case that they brought in, has been acquired. Same with Microsoft. And it is an interesting question of, is the same going to occur in our industry? For example, if you need to build a thin client flight computer or a thin client detect and avoid system, is that going to be our leading technology companies like a Honeywell or a Raytheon that is going to be capable of building an inexpensive and thin client product that's going to work in a VTOL that is either $30,000 because it's a drone, delivery drone, or it's $700,000 because it's a VTOL. And to get, we'll talk a little bit later, strong proliferation, we need that size. I have another concept which I talk about a lot, and again, this is going deep, is will our aerospace companies be able to pay the type of multiples that technology companies need to perpetuate the cycle of venture capital investing? So typically we have our aerospace companies that trade at, let's say, in a good day, 15 times earnings. That's 15 times the net income profit they make. Well, technology companies, even early stage, it doesn't even apply to, but let's say mid stage where you have some revenues, they tend to trade at 10 times revenues. That an acquisition like that would be highly dilutive to an aerospace company, and it's yet to be seen whether our aerospace companies are going to be willing to pay multiples and valuations of that. And only if they are we going to be able to encourage future venture capital to continue to come in our industry. Now, a quick thought, as I mentioned, Google, Apple, Microsoft, these have all been acquisitive companies. Most of their future technology comes in acquisitions. And is our space, is our industry going to end up the same way? I also want to talk about the concept that certainly in the VTOL space, fundraising prowess matters. And that means if you show you're able to raise significant amounts of money, are you able to push out all the other players in the industry? Because now they've basically taken up most of the capital available. And I do fear that certainly in the VTOL category, not necessarily in the UAV category, the drones, that might be the case. That you're going to have a few leading players that are going to demonstrate their ability to raise capital and push all the other smaller players out. Doesn't mean it definitely will happen, but we have 3 large players who've raised significant amounts of money. And if they continue to do that, will there be available capital for potentially the newcomers that have better ideas, maybe a better aircraft design, but they aren't able to raise the capital because it takes $1 billion. So I'm going to go through this. You guys know, here are some of the VTOL programs that we have. Here are some of the investments that have come from our historical strategic type investors. And the question is, we've also haven't even bring us talking to discuss the automotive industry and supply chain coming in here. One of the big cases that we also discuss is, what is the volume of production? And I know this is key to the supply chain conversation we're having here. If, and McKinsey has talked about this a lot, if in a mature market, our industry is only making 1,000 cars a year, or VTOLs, that is going to significantly limit the overall total addressable market, which is important that we have available. And it also will severely impact or significantly impact the cost per operating seat mile, which has a great deal to the premise of the whole industry. Is it going to work if we can't get these low seat miles? And we throw that back to you. Can the aerospace industry adapt to these high unit numbers that we see? Historically, Boeing and Airbus have only produced about 1,000 units a year. And if you look at the automakers, you know, BMW produces 82,000 a year. So who is going to control the future of passenger? Is it going to be the automotive industry, or is it going to be the aerospace industry? And I think it's yet to be determined. That question still remains. It also is a question of, what are the assembly lines going to look like? If you walk through a Textron assembly line, it looks vastly different than a Tesla assembly line. And I think if we're going to get that operating cost benefit that we need to really see proliferation of this industry, it's going to need to look more like Tesla, highly automated. So I'm kind of walking through. The last thing I want to discuss, and we'll kind of open this up for conversation, is how is our world going to look in the future? And this really is going to be severely impacted by whether there are synergistic conversations and qualifications between the regulatory agencies that control our industry. So it used to be that FAA, EASA, and CAAC worked very closely together, and that one didn't really make a move without the other. One of the negative impacts of the MAX and the Boeing MAX is that these organizations and the tight collaboration they had before has really disintegrated. And now we have isolated and really siloed regulatory bodies. And that has become even more demonstrative in the UAV space, where each of them is approaching how we certify aircraft and what those qualifications are. And I am concerned that we're going to have a siloed world where you have the Chinese CAAC certified world, the EASA world, which may actually include, you know, Latin America or Canada, and then the FAA world. And if we don't see some greater collaboration and synergizing of what the regulations are, I am concerned that we will have companies who have to build to very different models, and it will severely limit the future of our industry. So I always joke that when we talk about the supply chain, and I know we'll get into more detail about that, this is to some extent a call to arms for our industry and the need to really start thinking about this ahead of time. And I give PK and NASA and Dana a huge amount of kudos for really encouraging everyone to think early about how are we going to supply this this new advanced air mobility world that is coming in the future, and I was speaking to a well-known consultant in this space, and he described it as a multivariable equation, which makes this even more difficult to predict. One, what are the impediments to our industry going to look at, but also where do we have to be focused? It's like the known unknowns. So, but all of us believe the more thinking, conversation, discourse we can have about what our future looks like, the better off we'll be. So I will leave it at that, and hopefully I left you all with some ideas to discuss and debate.
Dana, you are on mute.
Okay, can you hear me now?
Yes, we can.
Okay, sorry about that. That was great. I think, the financing side of this is something that a lot of people, as openly as they do the technology is on its own. So it's good to have that perspective and to hear real numbers thrown around. One thing, you brought up the potential for there to be a regulatory sort of siloing globally. Last year, China and EASA signed a bilateral aviation security agreement that went into effect, I believe, last week. And I think, we're tracking very closely what comes of that. I mean, sometimes those deals are signed and they just kind of gather dust on a shelf. And sometimes they're signed because there is an underlying motivation for doing that. I just wonder, do you see that cooperation between EASA and the Chinese authorities as a growing sort of opportunity for both of them? Or is this more of an agreement that was just done as kind of a diplomatic overture?
I mean, Dana, I think it's a great point. I do think that is an opportunity. The FAA had a significant role in developing the CAAC, how it was built, how it was organized. And the CAAC mirrored many of their organization and regulatory on the FAA. But clearly, as we all know, that our two countries are now looking to kind of separate our approach to the world and really build alliances. So I am concerned that, listen, I think it's good for our industry to have a tighter alignment between EASA and the CAAC. I think we need more of that with the FAA. And what we're seeing now in certainly the general aviation space as well as the commercial is what used to happen is the FAA used to sign off on some sort of change and EASA just used to check it off. But now they're having their own individual approvals. And it's that type of environment where we have the duplication, even in triplicate, that is going to make this industry and certification even more and more costly. And we need to do everything we can to encourage alignment and to drive down duplication.
Yeah, I think that's a terrific point. PK, do you have anything to add, or should we go over to some questions? I'm not sure what do you want to do next?
Yeah, we can certainly go over to the questions. I was going to just add that having a multiple certification is also hard for suppliers who want to get the production certificate and supply multiple eVTOL companies. I think it's easier and more cost effective, and it's good for regulators, good for suppliers, good for the entire ecosystem and the total cost. We really need to look at the total cost of this, overburdening or redundant things need to be reduced to a point where that's absolutely necessary. So, yeah, I completely agree with that. But yeah, let's go to the questions. I think it was great. Thank you, Kirsten. That was a great conversation, and I assume you're open for people coming in with proposals for financing, and you didn't really advertise your company, which was very nice of you. But I'm offering that, I guess. It's something that you would be willing to entertain our suppliers, who would be suppliers and people who need funding. So thank you for that.
Very interested. Absolutely. Thank you.
So let's go through questions. There are 3 hands raised, so why don't we go through those first quickly, and then we go to Conference IO. So let's go with Adam.
Thank you, PK. I thought this was a really wonderful presentation. I really liked the comparison between the automotive sector and the aviation industry. One of the things I would really encourage this working group to look at is areas of synergy with the automotive sector. Because if we assume that safety is first, the automotive sector is the next ability to bring down costs, I think, or other industries that have that large supply chain. So I just think that as we start proceeding forward, we should kind of have that discussion of where are these synergies with these, larger volume sectors that we could leverage off of.
Yeah, and we have started to look at, just to give you an example, Adam, right now, the VTOL and the drones are a little bit different at the moment, but the VTOLs need parts that are so there are 3 phases, right? So there's a before certification, so you're still in the prototyping stage. You need fewer parts, so there's less incentive for mass volume, mass production entities to be part of that kind of boutique precision parts in the beginning. But as the scale improves, definitely that's the entities that we would be looking to also bring them in. And you need separate supply chain, of course, for cars and eVTOLs and all, so they don't interfere with each other and maintain the resiliency. But there is opportunity space because of the know-how and other things. There are some subtle differences in terms of the tolerances, the temperatures, and basically the fatigue properties and few other things related to aerospace, and that need to be looked at. And then as we start to cast into how the new old suppliers or previous different types of suppliers enter in. But those are all something we will be interested in helping through this work group. But I will go to the next question. Sorry, Dana, where are you going to say?
Yeah, I just wanted to add, the relationship between strategic automotive investors and their VTOL partners is very much a two-way street. And by that, I mean, the automotive manufacturers are not used to working with the materials, the aerostructures in particular, that VTOL is going to need, right? You don't see, outside of maybe a Formula One team for the automotive side, that anybody's working with, carbon reinforced, pre-pegs or thermoplastics. So in some ways, the startups have kind of been teaching the automotive side about how to lay fiber and about how to build aerostructures. So it's not all about, the manufacturers saying, yeah, we're going to automate everything and turn it into an assembly line, a la Henry Ford right away. They've got to learn how to work with those materials at scale too. And that's a pretty steep learning curve. I know there are several big, thermoplastics and thermoset manufacturers who are chomping at the bit to really do that, right? So I don't think it's a lack of willingness in terms of the suppliers. It's just it's a lot of knowledge that needs to be transferred to automotive, and that process is ongoing, but it might slow things down a little bit.
Yeah, let me take a next question here. Give me a second to see. This next question is from David Barra from FIA. David, please go ahead.
Good day. Thank you, PK, and good day, everyone. Interesting presentation. Thank you very much, Kirsten, for the presentation. I'm actually curious and want to ask more about the EASA side of it. I am one of the EASA point of contacts for the FAA at AFS 370 and representing AFS 300. My question is, can you go more into detail? What specifically are we talking about regarding EASA? I work with EASA all the time, especially when it comes to repair station certifications and also inspections here in the United States. So I'm constantly conversing with them as well as Singapore. Yes, there's some discussions regarding China, but I want to hear more detail from you, what you've heard or what you're seeing, because yeah, we're seeing some pushback, but especially nowadays with what's going on in the world. So yeah, I agree, the synergy is not quite there yet, but FAA and EASA is working closely to smooth things out. But do you have more details on that?
You may have more details than I do, so I always welcome a conversation offline. A lot of my experience comes from two kind of multi situational. One is talking with the general aviation aerospace manufacturers who are having great difficulty getting EASA sign-offs for things that the FAA has approved, and that is causing an enormous amount of additional time and work and delays on their part. So that's just, you know, how the old world used to work kind of prior to the MAX, honestly, and you know that better than I do. I think there's the second part about the standardization and the standards. So are we building VTOLs for, you know, 10 to the minus 9, or are we building VTOLs, you know, 10 to the minus 7? What are the appropriate? Are we doing specifics in our rulemaking, or are we doing a level of redundancy, which is the, you know, the FAA approach? And I also, you know, I think the tough part is that we don't have anyone, or I haven't heard of anyone going through the certification process with both organizations yet. And the interesting feedback I do get from the VTOL manufacturers I speak of is they say nothing but exceptional things about the organization they speak to. For example, the guys working with EASA rave about their collaboration, the back and forth, their assistance at every level. And honestly, the US guys going to certification with the FAA are saying similar sort of things. So I've been unable, because we have no one who's interacting with both organizations from a type certificate. It's really hard to differentiate and understand where the organizations are. And China's an entirely separate issue. I will admit to being wrong about China. I spent a lot of time in China in, you know, the early 2000s with the CAC, with an OEM, and I did not think that, I thought that they would be very reluctant to certify an aircraft. They've been a very safe aerospace organization, FAA, a regulatory organization. But what I failed to recognize is that they also ignore a lot that occurs in their aerospace. For example, there's been a lot of black charter with helicopters for the last 10 to 15 years. Like, we all know it has existed, and no one talks about it. And that's really what we're seeing today with EHang. Like, and I think it's going to be a big advantage in China, which is an interesting approach, is that because they're going to say it's an experimental, but you can fly people under an experimental, and we're not going to police that significantly, that I am concerned that EHang is going to get a lot of operational experience, and possibly at the expense of human life, that the other VTOLs are not going to get in their respective, you know, siloed regulatory environments.
Okay, and I have a better understanding, because you're referring more to the eVTOL. Those discussions are more likely going on at the executive level between EASA and FAA for the eVTOLs and urban air mobility. But just for full disclosure, I am the AFS 300 UAS division representative for urban air mobility, so along with other groups. So that's why I'm wearing several hats here. So when you start talking EASA, of course, my ears perked up, and it's like, okay, I'd like to find out more about it. So thank you, and thank you again for your presentation.
And I'd love to connect and, you know, share offline too. I know we don't want to monopolize the conversation, so.
Well, I don't know if my information is posted there on the presentation here, but my email is david.ibarra@faa.gov.
Great. I'll send you a note. Perfect.
See, Kirsten, you're a pretty high-level crowd here. Another thing I wanted to point out is, you know, in speaking to some of the OEMs, I mean, you talked about, you know, EHang and the potential for there to be, you know, a mishap, and not specific to EHang, but, you know, realistically, I think there's a second wave of OEMs, and, you know, you mentioned that there's this first wave that's raised an enormous amount of funding, and there's a concern maybe they're elbowing the second wave out of the market. We'll see. But I will say that some of the OEMs who are not part of the first wave, but are kind of still in stealth, or you know, haven't started flying yet, have expressed to me a little bit of apprehension, saying, man, you know, we're trying to be as deliberate as possible about our development process, but we know that in doing so, we run the risk that somebody's going to come out ahead of us, and maybe something goes wrong, right? Either just systemically it's just kind of mishandled and not efficient, or doesn't make money, or that there's some kind of tragedy, and that might sour, you know, opinion on the market as a whole. And so, you know, you, through no fault of your own, if you're one of these guys that's in that kind of second wave, you know, things could dry up for you based on just basically current events among that first wave. So, I mean, hopefully that isn't what happens, but it's certainly a risk in being, in that second tranche.
I absolutely agree with you. And I think we also have to recognize that the MAX and basically the flight computer are having issues. And I mean, that was a step towards autonomy, whether you call it pilot assist or, you go from up or below, that dealt a deep blow to our industry and just what the FAA has had to deal with. Now, hopefully we'll be safer coming out of that. But I did often say if that had happened to a Textron, if that had happened to almost anyone else besides Boeing, what we viewed as the gold standard, there would have been some more acceptance of, oh, well, it wasn't Boeing, it was these guys and they're not as good. So I absolutely agree with you that that it could delay the rollout significantly if we have some problems. And I think that's also why you see these companies who are developing the VTOLs say we have to operate them as well. We have to be the ones in control of the operation. We're not going to sell our units for the reasons of safety.
Yeah, and that brings up another topic, which is MRO, right? I mean, I'm not really sure. The OEMs are somewhat restricted in the types of maintenance they're allowed to do, at least under current legislation, or regulation. So, there will need to be also MRO development, right? And I know a couple of firms that are doing that now for the commercial small drone industry, who are quite interested in standing up, basically the preventative and periodic maintenance aspects of it, which are the ones I'm under the impression the OEMs are not supposed to be directly involved in. But, that's another piece of it that's going to have to come to light, whether it's a vertically integrated firm spinning off an MRO, structuring it in a way that lets them do MRO work, or if it arises organically. But it's certainly going to be one of the key enablers. And there are only, as far as I know, a couple of startups that are dipping their foot in that. And it seems like it's going to be increasingly important as they roll out.
And I think that's one of the areas you're going to see this more in drones and cargo drones, the proliferation, the MROs coming out, because you'll have commercial operations. The drone manufacturers certainly don't want to do that part of the industry. And then they'll be able to get commercial successes, some experience building out their infrastructure, which is so important to the MRO space as well, that by the time we really see the VTOL revolution be certified and approved in actuality, they'll have a much larger, footprint and infrastructure to be able to manage and assist in that.
Yeah, totally agree.
Great. So let me take some more questions from the audience here, and then move to the chat on the conference IO quickly. So the next question is from Alfonso Lopez. Alfonso, please proceed.
Sorry about that. Can you hear me? Yes, can you hear me?
Yes. Yes.
Okay,
yes.
great. Thank you very much for the presentation, Kirsten. I really appreciated that. And there's so many factors that are intertwined here. I just wanted to touch on one, and that's with regard to certification and materials. Most of the playtime gets on automation, pilot assist systems and electronics. And as much as we want things to be Stone Age things put together and modular, the structure itself, I think, is really fundamental. And I had the opportunity to field talk on the Agility Prime ecosystem, and one of the questions I got is, well, what materials do you have that are certified? Because it sure seems like these are very unique aircraft. There's designs that have never come up, and they have requirements that are unique. But at the same time, companies want to use materials that are established out there, certified, and are known or safe, but they may not be really that appropriate, especially if even a fraction of the vision of this comes to fruition, and we have thousands, hundreds of thousands of these things flying. So do you have any proposals with regard to financing and helping companies through this, because it's also very expensive to certify material. It's just a fraction of what it takes to get the whole vehicle up and running. But nevertheless, the material side of it and processing is still a big unknown. And materials that are out there today may not be fully appropriate. And Tasian is a material supplier. We would certainly love to be working with eVTOLs, but I mean, they're obviously secretive. They have their own funding and plans, and really it's not that many materials that are certified on a public forum. They're mostly internal. Boeing, Airbus, Lockheed, whoever is using it, they have their own database, and they're not going to share that. So, if you could speak at all toward any strategies you would have for facilitating material certification, acceptance, and I guess development, that I would appreciate it.
PK, do you want to take that, or Dana? I think I have to say some really good things about Agility Prime and AFWERX. As we went into COVID-19 and the commercial aerospace, industry hit a big bump, so strategic investment dried up, and then you had investor capital. It is incredibly important that the government step in and focus on these materials like support for the industry. And I like the fact that they're doing it in small checks amount. So they're not large checks, but that means it can be spread out amongst a lot of different companies. But you bring up some great points, and I think they're valid, and I think we're all concerned about them. Because what you use to create your production aircraft is vastly different material than what your prototype is done with. And we've watched companies like Icon run into issues. Like, they were able to get their aircraft up and running, but they weren't able to have a process that was certifiable. So the company effectively had to do an entire restart, and the shareholders lost control of it because they had planned for their production certificate in a way that wasn't certifiable. So I don't have a solution. I think we're going to have to be nimble and adjust. And unfortunately, as I look at this, have businesses which are in kind of the old world that we make our money on, and then use that to kind of fund research and development in what we call the new advanced air mobility world, and be patient and wait until that really takes off. Because, I think it was Nick who made a comment, I don't think this will be fast. If we see a VTOL certified in 2023, which is really aggressive timing, but could very well happen, you're basically going to see 2 to 3 years of low-level production and low-level operations. So we're really talking about a timeline before you get up to any sort of volume in a 7 to 10 years. So we need patient capital. We need to make reasonable investments in certain areas, but not ramp up too much so we run out of money early.
I'll just chime in with respect to that question too. I am aware of at least 2 materials that were developed using DoD funding in partnership with private sector advanced materials firms that are potentially suitable for eVTOL use, but the IP is owned by DoD. And so what I'm trying to do, we're working through channels within DoD to see if we can get the respective offices that funded that research to release that IP back into the ecosystem so that it can be incorporated. So there are a couple of materials floating around that at least DoD believes in that we might be able to shake loose that might meet the need too. But completely get your point about the certification process, and it's one of the things we talk about within our internally with Agility Prime. What are the other in-kind things that we can do? Yes, we have facilities. Yes, we have wind tunnels and echo chambers and things like that. But we also, can have some internal discussions within the government and the interagency to see how we might be able to catalyze, not just certification of whole vehicles with FAA, but certification, down lower levels in the ecosystem, like you're saying with materials.
Yeah, and what I would say to Alfonso is that please be on our electronic exchange portal, which I think you already responded to RFI, but we have number of people already responding to that, and we are going to allow that portal and the modeling and simulation over a period of time that's related to that will allow you to do and others to do material trades. So the trade-off between different materials based on the composition, the properties needed, would be something that the modeling simulation at the macroscopic will allow you to do. It's possible many times that certain material is not available and you have a production lineup, then you want to be able to replace it with something else. So I think the whole idea of this modeling simulation environment we are building, Agility Prime and NASA, and then the electronic exchange platform is to offer that kind of a flexibility and access to the suppliers of all kinds, from avionics to materials, to be able to address these issues. So yeah, I appreciate your question, and keep at that and be part of our ecosystem working group, as well as the electronic exchange platform that allows you to have a better connectivity and OEMs to have access to you. So thank you for that question. I'm going to go to conference IO and then come back to the raised hands here, if that's okay. So the next question is, how many different forms of navigation would be appropriate to ensure acceptable redundancy? GPS, DME, NDB, IRS equivalents. It seems like a question a little bit more for certification, but I don't know if Dave Barra, if you want to take that on, or Dana, if you wanted to add anything. But usually I think what I had seen is a triple redundancies, but that seems like more of a certification question. Any thoughts from anybody?
Hey, PK, can you repeat the question real quick? This is David again.
Sure.
My
Yeah.
audio decided to cut out for a bit.
Yeah, no problem. Thank you, David. So how many different forms of navigation would be appropriate to ensure acceptable redundancy? For example, GPS, DME, NDB, IRS equivalents. So they are looking for how many different forms of navigation is needed for redundancy.
And if we're talking eVTOL and urban air mobility, that's actually being discussed as we speak. Usually in the regular aviation world, we like to see at least 3 for commercial aircraft, but for eVTOL, it's still up in the air. So that's actually, like I said, being currently discussed.
Yeah, thank you, David. Yeah, appreciate that. Any insights on the thought process that goes into figuring that out would be also valuable, David. But if that's not possible, that's okay. We can move to the next question. All right, we'll move to the next question. This, I think, is for you, Dana. Looks like, has any company achieved the Agility Prime goal of 3 to 8 passengers, even for a short flight? Will any by December?
Well, I will say, I'm under a couple different NDAs, so I don't know that I could talk too specifically. I mean, obviously, we are in the realm of manned flight now, untethered. I don't know of any that are more than 1 or 2 passengers that have done that. I don't want to predict the future, but I would say, we will have several prototypes flying with at least a pilot by the end of the year, in all 3 of our areas of interest. But they may not be flying at full capacity in terms of occupants, right? So they'll be empty seats. That's about as specific as I can be. I can tell you, as from an Agility Prime standpoint, we feel like we have a good and growing sort of stable of different designs, multicopters and tilt rotors, and they span the gamut of design philosophies. So we feel like that portfolio of aircraft is a nice mix, which reduces the risk of not delivering on any of the AOIs. So I think we fully expect the firms that we've announced and a couple more that are pending, public announcement, that, there's enough activity there that, we're very satisfied with that we've got a critical mass of viable vehicles that are, going to be doing good things by December. And of course, then thereafter as well. And of course, we're collecting data on those flights so that we can, enhance the argument for certification down the road.
Yeah, thank you, Dana. So I'll take one more question from here, Conference IO, which is, if you were to give an equivalent wish list related to unmanned aircraft development in order to mitigate risk and maximize safety, what type of list would you ask for from the manufacturers? So I don't know if that's something you want to pick up, Dana, and I have some thoughts. Obviously, David might have definitely some good thoughts.
Yeah.
But usually, yeah, go ahead, Dan.
Well, I was going to say, I'm not sure that it necessarily goes directly to safety, but to the economics and the range. I think we talk a lot internally about how nice it would be to have, an eVTOL optimized hybrid hydrogen fuel cell battery propulsion system, right? And the potential for hydrogen fuel cell, to increase range is pretty transformative. And so, it's something we are tracking very closely, the firms that are doing it. Also knowing, and this gets back to the sort of Stone Age thing, there are several firms that are working on just basically diesel electric hybrids. And these are very advanced, very efficient very quiet diesel engines in relatively small form factors that would be paired then with the distributed electric propulsion. And, I think there are several firms now that are saying, look, we're not going to wait around for the batteries. We're going to just plow forward with the distributed electric propulsion, using an internal combustion engine. And, that's a way to make an entry in. And like I was saying before, to the extent that you're modular or have, the ability to swap out powertrains down the road, maybe then, you retrofit with something else. Now, I understand that brings its own potential headaches in terms of having to basically recertify if you make big changes like that. But so I say the wish list, the one, my sort of pet wish list piece would be the hydrogen fuel cell piece, but also understanding that, the early hybridized stuff might still be internal combustion, but it'll have the range that we would hope to see, eventually when fuel cell is adopted, hopefully.
Yeah, and if you are really looking for a wish list that is comprehensive of everything, then of course you have to expand it to include communication, navigation, surveillance, and control system, flight management system, and the software that's required to do that. Of course, Dana talked a lot about distributed electric propulsion types, so that's for sure. But there is a lot more for the list that's needed, and all that needs to be produced at a rate that and a cost that's affordable to reduce the cost per passenger mile, and that requires a significant robust supplier base for all of these aspects. So I think that's an important consideration to look at it when we look at the list. So there is we did a summer internship project for just smaller drones, and we identified a whole bunch of things that can be done in the United States. The different parts, these parts, some parts are not available, some are. So there is an interesting thing. Of course, a lot more to be done there, and this will evolve as we go along. I mean, this is the reason for this work group, and being part of that ecosystem that we're building is where you will see some of those things emerge. We take one more question from Conference IO and then go to. I'm sorry, Dana, do you wanted to add something?
Oh, I was just going to say, I don't want to put words in anybody's mouth, but if we were to ask that same wish list question of the OEMs, I think they would answer it with one word, and it would be autonomy, right? I mean, the economics are much better with an autonomous system. Obviously, that has a bunch of different moving parts, right? It's not that simple, but a trusted, trustworthy, certifiable, autonomous stack for a vehicle. I mean, that's that's probably way up the list on most of the OEMs kind of wish list.
Yeah, which requires microelectronics and trusted microelectronics and all the whole bit. So it's good. So let me take one more question from here and then go to the hands raised.
PK,
Sorry.
PK, this is David Ibarra. I'd like to add to that. And my apologies for cutting in here.
No, please do.
Some of the things that we're looking at also when it comes to the eVTOLs or even the urban aircraft that we're looking at, we should consider also looking at the smaller drones, the SUASs, because the technologies that are being created for those SUASs can be used in developing a platform for the eVTOLs and larger urban aircraft. For instance, you have some manufacturers out there that are creating full obstacle avoidance technologies that is impressive, and that can be easily used for the eVTOLs, and again, going towards the autonomy part of it. So even though you're flying an urban aircraft in the national airspace, and we have AI that's being implemented, you still need something to be able to, they're not going to use ADS-B, or they may use ADS-B. Currently, the system is almost maxed out. So they have to come up with new technologies. So we should look at to the small UASs and the manufacturers to be able to see what can be utilized already, almost like off the shelf, and then take it out to the larger aircraft. And with that being said, there's a whole process in regards to certification to be able to certify these parts, components, and avionics systems onto the urban aircraft, besides certifying the entire aircraft as well. So FAA is going to be involved in certifying the aircraft, certifying the systems that go into this aircraft, all at the same time, while you have FAA operations and air traffic looking at creating the airways and certifying the airways, and also working with NASA currently with urban air mobility, which I'm a part of that group as well. I think PK has that information as well. But so we're all looking at this at the same time. So while everyone's looking at the operational side of it, we shouldn't negate the airworthiness side of it at the same time. So now when it comes time to have a fully functional urban aircraft along with the airways, everything's already certified and it's ready to go, both from an FAA perspective as well as a NASA perspective. And that's what OEM should be and is working with NASA and FAA to be able to get that going.
I have a
good
quick
point, David. Thank you.
Hi, this is Mike DeCosla, Drone Industry Systems. I was the one who asked that question. I just have one thing I'd like to interject on.
Yeah, go ahead.
Thank you for taking the time to help us with this information. It's very helpful. So from a standpoint of procurement for that question, is there anything out there right now that will allow for us, for us to actually take this into a step process? In other words, here is the like a CRM system. Here is the procurement system, and here are the qualified parts and modulars that are already out there that we can actually go ahead and use as a system for everybody uniformly. Is there anything out there like that for a procurement system?
So one thing I can say, Mike, that is our aspiration to build this electronic exchange platform that we are undertaking with DoD Agility Prime. Exactly what you're saying. That system doesn't exist for aviation. There are other systems out there, other platforms out there. I know at least 3 or 4 of them, but none of them are specifically targeted to aviation and AAM and small drones. And it is because of the industry's basically need and people coming to us and saying, we need your help. That's why we are teaming together with Agility Prime and NASA, teaming together to build this up. We also have, by the way, FAA, as you heard, David, very active member here, as well as Department of Commerce. So we are trying to generate all government alliance, so to speak, to reduce friction, to get you that kind of access and support. So bear with us. I mean, we did RFI. If you haven't replied to the RFI, Mike, please go ahead and reply and send in the information about your company and the kind of things you produce and supply. We have many other, I think by now we have over 400 members replied already, and we are building this supplier database, electronic exchange platform, which will be sort of one step towards the modeling simulation, which is where we really want to go also. But we want to help you reduce that friction, figure out who is the trusted suppliers who has FAA production certification of different types. All that information will be embedded in that platform, and that's kind of the goal, is for OEMs to find suppliers who have that kind of certification, who have that kind of capabilities, and the suppliers to find other suppliers to team up with each other, and suppliers to find OEMs through this network. And I'm really glad to hear you say you asked for it again in a different way, because that's kind of exactly what we are on that together with Agility Prime. We realize this need, and we're working together, all government working together to help address this.
Thank you.
Okay, let me take one question from Conference IO, and then we go to two questions that are pending here in the teams. To be however efficient, a VTOL aircraft needs large rotors, having low disk loading, otherwise the power demand is very high. However, large rotors are detrimental to wing-borne cruise performance, a conundrum of all VTOL concepts. Since the creation of the first VTOL aircraft, how eVTOLs are dealing with this conundrum. So it's the asking for the balance of the size of the rotors for cruise and hover efficiency. Any thoughts on that from anybody?
Well, I'll leave a detailed answer to the aeromechanics folks, but I mean, it's obvious just from what's flying now that they've taken a broad array of approaches to that trade-off, that trade space between, and again, the acoustic factor plays into this too, because your tip speed and your diameter are going to play a major role in your acoustic signature. And I can tell you one of the things, in Agility Prime, we have a kind of array of capabilities that we offer to our to the firms that are coming into the program, and one of the most frequently requested pieces of in-kind data gathering and facility use is around measuring acoustic signatures, right? Because I think there's a big there's a lot of concern about public acceptance and how loud these things could be. So it's one of the first data points, and it's sometimes difficult data to gather. But so you'd be surprised. There's the aeromechanics piece and what's the most efficient configuration and diameter and speed. But there's also this big concern over public acceptance too. So you might see some solutions that look a little bit intuitive, or maybe suboptimal aerodynamically, but are there because of acoustic concerns.
Yeah, thank you. I will go to next question, Johnny Doe. And then after that, Robert Yancey, please. Yeah. Hey, Johnny, go ahead, please.
Hey, this is Johnny Doe. Good morning, PK, and good to talk to you again, Kirsten. And by the way, great presentation, very informative. Thank you. I have a question. Basically, we have and maybe opportunity question. That we all know that the high cost of a new aircraft program in the past has always involved in not only the type certification, but also the factory assembly, the production certificate, and link up to high cost and complexity to all the supply chain development and supplier certification. That the whole thing add together really is resource intensive, especially for startup companies and new projects. Now, my question is, we have never seen this many new projects happen at the same time before. So the opportunity may not exist in the past, but is it possible now that we have so many people and a lot of them are startups that we could say put a dozen or two of the company collaborating together to establish 70–80% commonality in the quality system, in the supply chain organization. And maybe team up with FAA, say, hey, we have all these common suppliers that we don't have to go through one-on-one. Every company goes through the same process over and over again. FAA doesn't have the resources to support that anyway. Is it possible to have some kind of grouping, some kind of teaming operation to help the whole industry as a whole to make more companies successful?
Kirsten, do you want to take that?
Yeah, no, great question, Johnny. I mean, one of the things that we have special session on is the standardization of some of the parts. So there's clearly IP restricted things that people want to do their own things, which is understandable. But the example I offered, the nozzle for electric charging, but there are many, many things like that, that if we can standardize those that really don't impact the performance, but helps reduce the differentiator between companies, but help reduces the cost for manufacturing and MRO, that really will help them, FAA, the regulators, and other regulators, as well as the manufacturability and the total cost. So it's really about the total cost, and I think we would do justice in setting up basically this group, adding information about what things can be standardized, working with OEMs, and to streamline those processes and reduce the time it takes for everybody. I completely am with you that there is a need to do that. Yeah, Dana, go ahead.
No, I completely concur. I mean, I guess the question for us, PK, is, how do we foster the development of that kind of collaborative community, right? Because I know the first thing I do when I'm trying to figure out, who's who in a landscape, in some of the emerging and enabling tech, is I go immediately to the industry associations, right? Because they've got, they're enthusiastic about explaining who their people are, and they've got a really good view of the landscape. So, to the extent that eVTOL had an industry association, I mean, I think DFS would probably be, the closest thing that we have, although I don't know, to what extent they're really involved in standards discussions. Gamma has taken an interest in this in a big way. So, I mean, they're already experienced in standards. But yeah, absolutely too. I guess the thing is, if you were going to develop a lot of commonality, I guess to me that kind of implies that your designs are going to start to coalesce around a particular configuration. And right now, the design space is so wide open, right? Distributed electric propulsion has allowed for, the creativity we haven't seen in a generation or more in aerospace, right? And so I think we're going to need to see a little bit more consensus around, what couple of configurations are probably going to emerge as the initial winners before we can really see commonality emerge in a big way. But I'm all in favor of trying to push it forward. No problem at all. Yeah.
Yeah. It's standardization where necessary, and unique IP where they want to have it. So that's kind of where our mantra is in that case. So the next question is Robert Yancey.
Okay, yeah, thank you. So Robert Yancey from Hexcel. So my question is if you look at the aerospace supply chain today, there's lots of excess capacity. But if you look at the projections, that capacity will be back up to 2019 capacity in 3 to 5 years, which is about the time that eVTOLs are looking at going to production. So are there things that the industry can do to take advantage of the excess capacity now while it exists and not get into the bottleneck in 3 to 5 years where the capacity might not be there?
Do you want that one, PK, or?
You can start and I'll add my thoughts. Yeah.
Well, first of all, that's the first I've heard of that kind of thought out loud, and I think it's a really good point. I'd be open to discussing kind of what components or what materials would there be excess capacity that we know will be, there'll be a demand for in eVTOL down the road a couple of years. So I'd be interested in hearing from OEMs about what it is that they, what parts do they think that they definitely are going to need along, in that time frame that they've locked down the design to the point where they're willing to commit to something like that, because ultimately it's going to mean running, accumulating inventory, right, which is going to be a burden on those small startups if they've got to do it. But I mean, maybe there's a way to incentivize or help with the financing of that kind of inventory accumulation. But yeah, I'd love to know what parts that would involve, because yeah, the excess capacity now, I mean, it would also stimulate or help keep the operations going at some of these aerospace firms that are kind of in neutral right now.
This is David as well. Sorry about that, PK. There's a process also. Oh, sorry about that.
No, please go ahead.
There's a process of once these OEMs, let's just say they have whether it be parts components or even an entire airframe that they want to certify, they can go through the aircraft certification office with the FAA and get a type certification. Once that occurs and they have a type certificate, now they're able to begin to standardize what parts and components they'll be able to utilize to be able to create an aircraft that is type certified and be able to bring it to an airworthy condition. So once the aircraft is type certified, just like a regular commercial aircraft, and it's out and it's operating, you have a type certificate that lists exactly what goes into that aircraft to bring it back to its airworthy condition, whether you want to add parts, components, or systems, or you want to remove. So, and when it comes to the urban aircraft world, or even the eVTOLs, OEMs should be looking towards the FAA in regards to getting a type certificate. That currently, if it's above 55 pounds, they can go through that process. And now it goes through the process of flight testing, testing out the systems, checkout of avionics systems. So once, again, they get the type certificate, they're able to show that they're conforming to a methodology that is safe in the national airspace. And that begins the process.
Yeah, absolutely. And then I'll add one comment and we had to stop now, I guess. We're running out of time. But while we are waiting, as Robert said, while we are waiting for eVTOL and certification, we can't really mass produce when we don't know the design and certificated means of compliance and such. There are things you can do right now. If you have excess capability, work with the drone industry. The small drone industry right now, some of them already got approvals, and I think they would be possibly willing to work with you to do production. There is interest in drones, smaller drones, as Robert also mentioned before, that there could be opportunities to support them in their manufacturing at the scale. There are a number of entities who have got approvals already and figuring out how to basically get scale up. So that's the right time for those who have excess capacity to go and help that smaller drones. This is why we have this work group, which includes both the small drones as well as VTOLs. So thank you for everybody's time. I think we're going to have to cut short here, unless Rice, you have a quick question, so we can go to you. But otherwise, we have to cut short here. We're a little bit behind. We can take up these questions, by the way, next time too, or we can interact with you offline as well. Please don't be shy in sending your feedback and such. But this was a great conversation. Thank you for spending time with us, and we are all helping each other here. So don't be shy of telling us what we can do differently to improve it. Provide your feedback on that email address you see there.